The universe is vast, beautiful, mysterious, and for the most part, predictable. Stars orbit their galaxies. Planets follow their paths. Gravity behaves the way we expect it to. Light travels in straight lines. Matter stays where it should. But not everywhere. Scattered across the cosmos are objects so extreme, so powerful, and so utterly beyond our everyday experience that they stretch the laws of physics to their breaking point. These are places where matter collapses, light bends, and the familiar rules of reality begin to unravel. They are reminders that the universe is not a calm, orderly place, but a wild arena of unimaginable forces. Today, we're exploring some of the most extreme objects in the universe. And we begin with one of the strangest of them all: Magnetars. A magnetar is a type of neutron star, the collapsed core of a massive star that once burned many times brighter than our sun. When such a star reaches the end of its life, it explodes in a supernova, blasting its outer layers into space. What remains is a core so dense, so compact, and so violently compressed that the atoms inside it are crushed beyond recognition. A typical magnetar is only about 20 kilometers wide, roughly the size of a city. But inside that tiny sphere is more mass than our entire Sunday. Imagine taking a star 1,000,000 kilometers across, and squeezing it down until it could fit inside a small town. That's a magnetar. But what truly sets magnetars apart is their magnetic field. A magnetar's magnetic field is the strongest known in the universe, 1,000,000,000,000 times stronger than the most powerful magnets humans have ever built. If you were somehow able to approach a magnetar from 1,000 kilometers away, its magnetic field could distort the electrons in your atoms. It could literally tear apart the structure of matter. This isn't science fiction. This is physics pushed to its absolute limit. Magnetars are so powerful that when their magnetic fields shift or crack, they release bursts of energy that can be detected across the galaxy. These events, called starquakes, are among the most energetic phenomena ever recorded. In 2004, a magnetar in our galactic neighborhood released a flare so intense that it briefly affected Earth's atmosphere, even though it was 50,000 light-years away. To put their density into perspective, a single teaspoon of magnetar material would weigh more than 1,000,000,000 tons. That's the weight of a mountain, compressed into a spoon. But magnetars are not just dense, they are dynamic. Their magnetic fields decay over time, releasing enormous amounts of energy. Some magnetars emit repeating bursts of radio waves. Others produce giant flares that momentarily outshine entire galaxies. And yet, magnetars are rare. Only a few dozen have been identified in the Milky Way. They are cosmic oddities, brief, violent, and short-lived on astronomical timescales. But magnetars are only one type of neutron star. And neutron stars themselves are among the most extreme objects ever discovered. A neutron star forms when a massive star collapses under its own gravity. The collapse is so violent that the atoms inside the star are crushed. Electrons and protons merge into neutrons, creating a dense, exotic form of matter. The result is a sphere the size of a city, containing more mass than the Sun. Inside a neutron star, matter exists in a state we can barely describe. Atoms no longer exist. Instead, the interior becomes a quantum fluid, a sea of neutrons packed so tightly that a single cubic centimeter would outweigh Mount Everest. Their gravity is equally extreme. If you dropped something from 1 meter above the surface of a neutron star, it would hit the ground at nearly half the speed of light. Time itself slows near their surface. Space bends. Light curves. The laws of physics behave differently. Some neutron stars spin hundreds of times per second, sweeping beams of radiation across space like cosmic lighthouses. These are called pulsars. Their rotation is so precise that some pulsars rival atomic clocks in accuracy. Others emit bursts of X-rays and gamma rays as they accrete matter from nearby stars. Some have magnetic fields nearly as strong as magnetars. Some are so dense that their crusts, only a few centimeters thick, are stronger than steel by a factor of billions. And then there are the theoretical possibilities, strange stars made of quark matter, or hybrid stars with exotic cores. These objects may exist, but we have yet to confirm them. Neutron stars are nature's densest stable objects. Only black holes surpass them, and we'll get to those soon. But before we dive into the darkest objects in the universe, we need to explore another kind of cosmic extremity, one defined not by density or gravity, but by sheer, overwhelming brightness. Quasars are among the most powerful and awe-inspiring objects ever discovered. They are the brilliant hearts of young galaxies, powered by supermassive black holes that consume matter at extraordinary rates. When gas and dust spiral toward a black hole, they form a rapidly spinning disk. Friction and gravity heat this disk to unimaginable temperatures, causing it to glow with an intensity that defies belief. Some quasars shine with the power of trillions of stars. They are so bright that they can be seen from across the observable universe, even though the galaxies that host them are far too distant for individual stars to be visible. A quasar's light has traveled billions of years to reach us, carrying with it a message from the early universe. But the brightness we see is only part of the story. Quasars also unleash enormous jets of energy from their poles. These jets can stretch for thousands of light years, blasting radiation into intergalactic space. They carve through the darkness like cosmic searchlights, shaping the galaxies around them and influencing the formation of stars. These jets are powered by magnetic fields twisted by the rotation of the black hole and its accretion disk. As matter spirals inward, some of it is redirected along the black hole's magnetic poles and accelerated to nearly the speed of light. The result is a beam of energy so powerful that it can pierce through entire galaxies. Quasars are not just bright, they are engines of cosmic evolution. They regulate the growth of galaxies, control the flow of matter, and illuminate the distant universe. They show us that even in the vast emptiness of space, there are places where energy erupts with unimaginable force. But brightness is only one form of cosmic extremity. Some objects are defined not by how much light they emit, but by how fast they move. Hypervelocity stars are among the fastest objects in the galaxy. Most stars drift slowly through space, orbiting the center of the Milky Way at predictable speeds. But hypervelocity stars have been launched by violent events powerful enough to fling entire suns across the galaxy. Some hypervelocity stars were accelerated by supermassive black holes. When a binary star system wanders too close to a black hole, one star may be captured while the other is hurled outward at incredible speeds. Others were ejected when their companion star exploded in a supernova, sending them flying like cosmic shrapnel. These stars travel at millions of kilometers per hour. They move so fast that they will eventually escape the Milky Way entirely, drifting alone through intergalactic space. Imagine a star, a massive, burning sphere of plasma, racing through the darkness, leaving its home galaxy behind forever. Hypervelocity stars remind us that even stars, the most stable objects we know, can be thrown like projectiles by the forces of the universe. But not all extreme objects are fast or bright. Some are defined by their isolation. Rogue planets are planets that drift through space with no star to orbit. They wander the galaxy alone, without sunlight, without warmth, and without the familiar cycles of day and night. Some were torn from their solar systems by gravitational chaos. Others may have formed alone in the darkness, never bound to a star at all. There could be billions of rogue planets in the Milky Way, cold, silent, and drifting through the void. Some may have thick atmospheres that trap heat. Others may have oceans hidden beneath layers of ice. A few may even harbor the conditions for life that evolved in complete darkness, without ever seeing a sun. Rogue planets challenge our understanding of what a planet truly is. They show us that worlds can exist in forms far stranger than the ones we know. And yet, even these lonely worlds are shaped by the galaxy around them. Rogue planets drift through regions filled with dust, gas, and radiation. Some may pass close to stars, heating their surfaces for brief moments before returning to the cold. Others may wander into dense molecular clouds, where gravity and pressure could reshape their atmospheres. A rogue planet's journey is long, silent, and unpredictable, a solitary voyage through the vastness of space. These objects, quasars, hypervelocity stars, and rogue planets, represent extremes of energy, motion, and isolation. They remind us that the universe is not uniform. It is a place of contrasts. A place where some objects shine brighter than galaxies, while others drift alone in eternal darkness. Now, we turn to the most powerful objects of all. Objects that warp space, slow time, and reshape the universe itself. As we look at these extraordinary objects, quasars blazing at the edge of the universe, stars flung across the galaxy at impossible speeds, and planets wandering alone through endless darkness, we begin to see a pattern. The universe is not static. It is not quiet. It is a place shaped by violence, motion, and extremes. Every one of these objects tells a story about how galaxies grow, how stars die, and how matter behaves under unimaginable conditions. And together, they reveal a universe far more dynamic and unpredictable than it first appears. Supermassive black holes are among the most mysterious and powerful objects in the universe. They sit at the centers of galaxies like cosmic engines, shaping the evolution of everything around them. Our own galaxy, the Milky Way, has a 4 million solar mass giant called Sagittarius A star. But compared to the largest black holes we've discovered, ours is modest. Some supermassive black holes contain billions of times the mass of the Sun. Their gravity is so intense that not even light can escape. Around them, space itself is stretched and twisted. Time slows. Matter spirals inward, forming an accretion disk hotter than any star. This disk glows with incredible energy. Gas and dust swirl at nearly the speed of light, heating to millions of degrees. Magnetic fields twist and snap. Particles are accelerated to extreme velocities. And sometimes, jets of energy erupt from the black hole's poles, beams so powerful they can extend for hundreds of thousands of light years. In 2019, the Event Horizon Telescope captured the first image of a supermassive black hole. A glowing ring of light surrounding a dark shadow, the event horizon, the point of no return. It was a moment that changed our understanding of the universe, revealing the true face of one of nature's most mysterious objects. But black holes are not just destructive. They are creative forces. They shape the galaxies around them, influencing the formation of stars and controlling the flow of matter. When they feed, they unleash enormous amounts of energy, lighting up the centers of galaxies and driving powerful winds that sweep across thousands of light years. Some galaxies are so dominated by their central black holes that their entire structure, their shape, their brightness, their star formation, is controlled by the black hole's activity. These galaxies are called active galactic nuclei, and they are among the most energetic objects in the universe. But even the power of supermassive black holes is rivaled by something even more violent: gamma-ray bursts. Gamma-ray bursts are the universe's most intense explosions. In a few seconds, they release more energy than the Sun will emit in its entire lifetime. They are so bright that they can be detected from billions of light years away. Some gamma-ray bursts come from collapsing stars, massive stars that implode under their own weight, forming black holes in the process. Others come from neutron star collisions, events so powerful that they shake the fabric of spacetime itself. When two neutron stars collide, they create a burst of gamma rays, gravitational waves, and heavy elements like gold and platinum. These collisions are among the most violent events in the universe. They forge the elements that make up planets, jewelry, and even parts of our own bodies. If a gamma-ray burst happened close to Earth, it could strip away our atmosphere. Fortunately, none are pointed at us. But their existence reminds us that the universe is capable of sudden, catastrophic events that dwarf anything we have ever experienced. And then there is the Boomerang Nebula, the coldest known place in the universe. Colder than deep space itself. Colder than the cosmic microwave background. Colder than any natural environment ever measured. Its temperature drops to just 1 degree above absolute zero, the coldest possible temperature. This happens because a dying star at its center is ejecting gas so rapidly that it expands and cools faster than the surrounding universe. The result is a vast cloud of ultra-cold gas, a cosmic freezer drifting through space. The Boomerang Nebula shows us that the universe is not uniform. It is a place of extremes, extremes of heat, extremes of cold, extremes of gravity, and extremes of energy. And when we look at all these objects together, supermassive black holes, gamma-ray bursts, and the Boomerang Nebula, a pattern emerges. The universe is not a quiet, gentle place. It is dynamic, violent, unpredictable. It is shaped by forces far beyond our everyday experience. The universe is full of wonders. Objects that bend light, warp time, and challenge our understanding of reality. From magnetars to quasars, from rogue planets to black holes, these cosmic phenomena remind us that the universe is far stranger and far more powerful than it appears. Inforyo. Facts that shift your perspective.